now we want to make more smooth boundary so the object can change its direction more smooth way. So first of all, I'm gonna create another cube and I will call this one as smooth agent. And let's turn off the bouncing agent and let's reset the smooth agent. And let's create another C# script and I'm gonna call this one as smooth bouncing. Just before we forget, let's attach smooth bouncing to smooth agent. Basically, the script of smooth bouncing is almost same as bouncing agent. So first of all, I'm going to copy paste bouncing agent script. And we're going to change just a couple of lines inside of here. Before we start, I hope you guys still remember class from the high school. Here is a vector addition. When you look at this graph, there is a u vector and v vector. When we try to combine u vector and v vector, the result is going to be this green vector, u plus v vector. So the idea of smooth way is just adding the vector to make object turn around. So I'm gonna add another vector. This desired velocity is going to be updated to velocity vector. So by doing this, direction of the velocity vector is going to keep changing due to the desired velocity. And now we need to figure out how to define the desired velocity. If you think about the vector addition, here is kind of the answer. For example, when the object is going outside of the boundary with this velocity, we need to make the object going inside of the boundary. In this case, the vector is going to be boundary x minus position x. This means desired velocity. And result of this combination, the updated velocity is going to be this green line. And this happens in every frame until this object is going inside of the boundary again. To write it down inside of the script, we need to use if condition again, but this time we need to divide when it goes up and when it goes down. So I will just copy and paste here. And if position vector x is larger than boundary x, we can say desired velocity is going to be boundary x minus position vector, which is exactly same as this example. And again, when it goes to the minus, all we need to do is change boundary x to minus boundary. So let's copy and paste this one. Well, before that, let's delete these 4 lines because we don't need this. And let's copy and paste this, then let's update to the minus. And this goes to exactly same to z. Now, the update part is divided into 2 parts. All the ifs are just checking the boundary, and these 3 lines are just updating the position. So not to forget, we need to add 2 more things. So first one is, since we're using the if 4 times, so we need to check if there is any confliction or not. So if you think about it, in this case, when the position vector x goes outside of the boundary, cannot happen with going underneath of boundary minus boundary x. So for that, it's better to have else if rather than just if, and it's going to go to same as z. So to avoid confliction, it's better to do this. And every time when it goes around in this update, desired velocity is going to be keep adding. But we don't want to have the desired velocity every time. We just want to have the desired velocity every time when it stays outside of the boundary, right? So we need to reset the desired velocity every time. If you think about the script inside of the update, desired velocity resets at the beginning, and after that it's going to check if the object is outside of the boundary or not, and if it is outside, it's try to turn around the object direction. if we check the result of this script, well, it looks like the bouncing ball itself. It's because strength of the desired velocity is too strong, so we need to reduce it. I will just make it multiply by 0.1f. And about the velocity, I would say it was a bit too fast because even the number was 0.1, it was not that slow enough. So I want to multiply by time dot delta time. So time dot delta time is time between the frame to frame. Well, if you think about the hardware, if you play this game inside of the good hardware, the time rate per second is very high. And if you play bad one, frame rate of the second is going to be very low, which means the speed of the game is going to be different in every laptops or every desktops. Time at a time is just for that, so it's kind of making average speed of in every hardware. So let's go back to smooth agent. Since we multiplied time at the time, the speed of the agent became very slow. So I will change the velocity number to 5. Now you can see that it is kind of bouncing but a bit slowly along the edge. If we decrease this number, the bouncing will be smoother. So I will change it to 0.05. And also I'm going to increase the speed of the velocity to 10. Now we can see that it is trying to stay around the boundary, but the change of the direction is very smooth.